guys, OCA here. Welcome to another manual home cinema calibration tutorial video. Despite the very positive feedback I received from the first tutorial on manual calibration, there were some small issues with the method. First, speaker volume alignment, which is very important especially with Dolby Atmos, was not possible with the plate sweeps because you cannot do check levels with a ping noise. And I had suggested to use the test tone of the receiver, but it turns out these test tones are playing with every correction bypassed, so they are useless. This includes audyssey correction as well. By the way, if you're trying to fix your speaker levels after audyssey with the test tone generator, it will not be including any audyssey correction, so you won't be hearing the real SPL level of that speaker. Otherwise, you could just play the test tones and measure with REW Set meter. That would be a solution. Also, some of you cannot see the acoustic timing reference chirps in the impulse response. Turns out this also is a problem with crosstalk with these receivers, and only people with very clean signal paths with no crosstalk between channels cannot see those chirps. So I had to come up with a different SPL alignment solution, and I decided to make this complementary video to show all the necessary steps for optimal home cinema calibration for Dolby Atmos. It's gonna be no longer or no shorter than necessary. It's really optimized. First, place the microphone pointing upwards at the central listening position with the microphone tip at ear height. For best results, front left and front right speakers should be equal distance from the LP, and center speaker and TV should be in the middle of front speakers, ideally. All floor speakers, tweeters should also be at ear level. All ceiling speakers should be pointing directly to LP unless you have very special tweeters with high degree of dispersion. When prepare your receiver for measurement, as explained in detail in the first video, all processing should be off, including audyssey, speaker distances, levels, graphic equalizer, all reset to defaults, and all speakers set to large with no crossover. Let's first start by fine-tuning the mic alignment. Just make sure it is exactly at the center. It's free trial software from Audiophile. Accourate trial, 4 days left, not very nice. Log sweep, microphone alignment, ASIO control. You have to make sure it's in the right thing. It's not real tech I'm using. It should be okay. I can't even select two things simultaneously, so you go to advanced options and open these branches. And now this is my correct NVIDIA output for HDMI output for the receiver. Your mic should be on, these should be all off. It doesn't have a reload button, but you can keep pressing ASIO control button. Okay, now we have all the correct play signs near the correct inputs and outputs. Now let's start with 44.1 kilohertz sampling rate. As you see, it's checking if the impulse peaks are on top of each other. Now, it's showing me, for example, to move it right, 3 samples length. So I move the microphone to the right, and now it's at 0. A little bit more. Now it's too much. So this is at 44.1 kHz. We can go up to 192,000. All these sampling rates may not work all the time, but now at 192,000 sampling rate, the accuracy of it is 1 divided by 192,000, 0.000005 seconds times speed of sound. It's accurate to 0.00177 meters, which is 1.8 millimeters. That's the accuracy. It's useful not only in just setting the speaker distances right, but also once the microphone is really in the middle of the two front speakers, you can check if your center speaker and TV are really at the center. It's quite important in that sense. Now I start. It will require even more volume. Be careful with the volume with this thing. After you finish, turn down the volume massively because otherwise you're gonna damage your speakers. It really requires very high volume to work. Now I'm at almost -2 reference level and it's working. One to the right, one to the left. I'm actually just touching the microphone at the moment. Okay, now it's aligned. So we are done, and we thank Audiophile for this free trial software, and now time to open REW Wizard. It's going to be open from default settings, so you see what I change. No for that because this is Java. Get rid of this menu. Preferences, sound card, ASIO, ASIO for all, which should have been installed in your PC. Open ASIO control panel, reload, untick unnecessary things. My UMIC is highlighted with a play sign. My HDMI out from NVIDIA graphics card is already highlighted, so I don't need to change anything. This is correct. Now I choose an output out of the 8 channels available, and timing reference output is center channel for me. Now here, when you don't have a chirp because of no crosstalk in your system, you should use whichever speaker you can measure the best or the easiest. Let's say it's your center channel, which you can measure the distance to the microphone quite precisely. Doesn't need to be very precise either, by the way, because this receiver precision of the distance is no less than 3 centimeters. So let's imagine it's center speaker for you and it's exactly at 3 meters, which is the case for me. And it's quite easy to measure. And input UMIC 1. Now it's asking me for the calibration file. It's not going to be separate calibration. It's not stereo. And 90 degrees because it's pointing upwards. You just upload this calibration and change subwoofer test signal to main speaker test signal. Nothing to change here. Make sure the calibration file is loaded. Nothing. Analysis, 8 frequency dependent window, 15 cycles default, and change no smoothing to psychoacoustic smoothing. So every measurement automatically comes with these settings applied. Untick loop peak delay references IR peak. In equalizer, you can use generic, but because I have a configured PEQ file that I will supply in the description area under the video, here you have to do some changes. Monos and Denon have 9 filters. Sample rate 48,000, frequency range 20 to 20, gain range is from -20 to +6, and the steps are 0.5, no less. RBJ stays, and this is not important really, but if you really want to be very specific, make it from 1.5 to 1.5, 0.01, I think is the lowest. Yeah. Apply changes. Target type none, and LF rise and HF fall should be the same. So let's make them 200 each, and the slope should be the same, 0.7, 0.7. This is a quite nice target curve. Drop filters if gain is small, unticked, and view, untick, use ticker traces and increase the measurement, maximum measurement number to 100, for which you have to restart REW. Restart it. Now in this video we will measure every speaker, including the floor speakers, with only played sweeps, which are going to be from 20 Hz to 20,000 Hz and only 250K sweep length, so only around 5 seconds. But for the subwoofer alignment, we need to measure with REW sweeps initially. So we are going to start from the subwoofer. Now 20 to 20,000 and 250K. The timing reference, I have to choose center because I know the distance of it. Now check levels, which you can with REW sweeps easily. It just sends a ping noise. 66 dB. Now for the same frequency range, everything the same, volume is the same, just drop down the highest frequency 250 like a subwoofer should be. Check levels. Suddenly 77 dB. Now why is this happening? Because when you send only very low frequencies, the receiver thinks it's an LFE channel signal. LFE is a special channel. That's the 0.1 channel that you always hear about, like 5.1, 0.4 Dolby Atmos. That 0.1 is the LFE channel. It's only used for special effects, special very low bass frequency effects in the movies, etc. by studios, and it's always boosted by 10 dB. You have to, I will use my web interface for the setup as usual. Entering its IP, you go to audio surround parameter, you will see a low frequency effects here, which is at 0 dB by default, and it only can go negative. That's because this is LFE channel volume and it's 10 dB boosted. To measure the subwoofer's volume properly, you have to change it to -10. Just don't forget to change it back to 0 after you finish the calibration before you start watching movies. Now it will not have this unnecessary boost, and we can see its real volume level. The subwoofer level adjust this one, and in the speaker's level adjustment, this one, this subwoofer, are identical. Whatever you change here will change also at the other area. But this LFE volume is different. It's separate for this channel. This is anything crossed over from front speakers, other speakers and whatnot. But LFE only is for the subwoofer. It is only active when there is a signal in the record for that specific channel, and there very seldom is. Now that LFE is taken back, now let's check levels at the same subwoofer range. Okay, now we see that our subwoofer channel has 70 dB volume. You can check another speaker, like center speaker, check levels. But obviously not for this bass frequencies, for channel centers. So that's also 70 dB by coincidence. You can align the subwoofer volume here. You can start changing it, like whatever is these other speakers in the system which you want to keep around 0. Like front left is 73. So maybe you should increase the subwoofer level a little bit. This gives you a ballpark figure for your subwoofer level, whether it's correct or not. But for timing alignment of the subwoofer. Now, we know that our center speaker is 3 meters distance. We measured it manually. So we go and enter the center from the default 360 to 3.00 set. And once you have that, now whenever you have center channel as acoustic reference, whatever you measure, the difference from that to time 0 will be the correct difference that you should apply to its distance. Now let's measure the sub again, and to correctly also time align it, you need to send it a low signal, because high frequencies are faster. So if you measure, for example, from 0 to 24,000, like normally you should, let's measure. Oh, not check levels. Let's call this subwoofer full range. And then now measure it from the useful, like my subwoofer will only function from 30 to 120, because I will cross over anything below 120, I know. And now measure. And let's go to overlays, and this one we call sub normal range, logical range, or whatever you want to call it. Go to impulse tab, change it to %. Now look at the two different subwoofer impulse responses. Let's make them more pointy. As you can see, there is easily 25 centimeter difference between the full range and the normal subwoofer peak, because the full range has high frequency 24,000 Hertz arriving earlier, which is a frequency that the subwoofer will never produce. The subwoofer will produce these frequencies, which are impulse peaks are here. So you have to align this one with the rest of the speakers. And now that we know for a fact the center speaker is at 3 meters, when center speaker was acoustic reference, so this was 3 meters. And our subwoofer is minus 3.4 meters, arriving too late. Don't confuse these things. This is the time axis, this is negative time, this is positive time. If a speaker is arriving in positive time, the impulse peak is at positive time, it means it's late, because center speaker is already at time 0. Let's measure the center speaker just for illustration quickly. I don't want that blue one. No, blue one stays actually, but I don't want the blue one is center speaker. As you can see, center speaker is always, the peak is at time 0, and subwoofer's peak is 3.42 meters off. It has arrived later than the center speaker. Okay, if it was here, it would mean that it arrives to the listening point earlier in negative time compared to the center speaker. So when it is a positive time, you increase the distance so that the receiver applies longer distance, applies less delay because it thinks that it's coming from a further distance. So it should accelerate and it catches up. What you have to remember is, because it's very easy to confuse, if it's at positive territory in the time axis, then you apply a positive difference to the distance. If it's at negative territory, apply a negative distance to the speaker setup. So 3.43 meters. I go to subwoofer and increase it by 3.42, which is gonna make it almost 7 meters. I'm not entering the exact number for the reasons that you know, that this is not accurate. It has to be a trial and error at some stage. By the way, I want to get rid of these dates. So remeasure subwoofer from 20 to 120. Okay, from here, this is time 0, it is already here, but needs more further adjustments, but you can do the rest. Now you have to decrease it a little bit. It's never 46 centimeters as it says there, so let's make it 780, 6.80. Set. Okay, even closer now, but you got the technique. I think you can bring it on top of 0, and once it's on top of 0, then subwoofer is time aligned. That distance should never be changed. Now the volume alignment of subwoofer, they both check 70 dB. If they didn't, okay, with the rest of the speakers, then you would align here the subwoofer's volume, whatever it requires. So this is how you adjust. Once you have the final subwoofer measurement, let's suppose it's this one or this one in full range, okay, you go to EQ window, get rid of waterfalls, fit data to screen. Okay, now target settings, calculate target headroom curve, obviously, so that you have the slope, and you have to move this all the way to the correct average volume of the subwoofer. That will be the target level. This is an easy hack against not being able to measure the volume levels of ceiling speakers. You bring this target here. I mean, this is the average volume, in fact, okay? Like equal parts up and below the target line. But this target line is not exactly the average, it's the dips limit target, the way it also handles the other speakers. So you keep it somewhere here. And this 65.9, you have to note it, it's your target dB level for every speaker. If you keep the subwoofer at this volume, here at 0. Whatever you picked here as, and picking it initially is just by check levels, because you're measuring with rev sweeps, it's easy to do. And then you don't change this after that one, and 65.9, you just generate measurement from target shape, and it will help you to remember. And the target you created here, you write down 65.9 dB. And this is your sub, time aligned, and you can delete everything else, including the sub actually. Now, you can start really measuring your speakers. You have a target level, and take back the LFE to normal. Sorry, surround parameters 0, because the sweeps will measure subwoofer in full range. And preferences, ASIO control panel, give control to Windows Media Player, but you have to see this message here that is reset, otherwise the volume will be lower of the sweep volume than it should be. Also make sure that in Windows Sound Playback your Marantz is your default driver. If it's not, also the volume decreases. I got these complaints, that's how I know. So one more reload, and now it doesn't have ASIO control. Now from file we have to do the sweeps, browse. I will supply these files, obviously. I will supply a link in the description area. These are the new files, 256K, 20 to 20 Hertz. Okay, and this is the wave file that you have to upload here, so REW knows what it should expect. And then you can start measuring every speaker, starting from, I will supply every floor speaker and Atmos channel, 16 of them, and you just press play. Windows Media Player at full volume. Okay, somehow REW, I forgot to press start, I guess. Yeah, you have to play start, so it expects for a acoustic reference signal, then you play the phone. Also you can skip the initial silence. Okay, now it's measuring. Center. Now go ahead and measure every speaker you have in your system. Start. And now front left. I will only measure 2 for this video. And let's also measure one top front Atmos channel, just for a show off. So this was front left, and this was top front left. You know how to time align those. These are all measured as large speakers with no crossover active, and time aligning is now all about checking the impulse peaks. Also checking the impulse peaks are all at the same direction, if not change the poles of the speaker, including the subwoofer. Center speaker always at time 0 because it's the acoustic reference, but front left is off by 91 centimeters. Okay, it has to be off, which means you come here and change the speaker distance of front left 91 centimeters, which makes it to 71 or something. Yeah, set. Once you do that, it should normally come right on top of the impulse peak, impulse time 0 here, but it is not gonna be. It's gonna be either to the left or right, and you have to fine tune it by moving back and forth in the speaker distance measurement because of the inaccuracies of the distance measurement system. Let me just measure front left one more time and show you. Play front left. You can skip until here. See, it's here now. So you have to dial it back a little bit, like this. And very quickly you will find the exact distance. At some point, no matter what you do, you will not be able to get closer to time 0, and this is where you have to leave it. In fact, I can show you what the best can be done with Marantz and Denon receivers, because the accuracy is limited. This is like perfectly aligned. Now let me take off the new things. These are perfectly aligned 5.1.4 system, and you can see that none of these speakers can come closer to 0 than this, okay? And here you can see that the top rear right is off by 1.7 centimeters, and this one is, what is it? Is top front left is arrives late by 1.4 centimeters, and the range is like from here to here, 3.1 centimeters. You can't get better than this with these receivers. Keep that in mind. Now, there was a way to remove loss loaded measurements. No. Yeah, this one. And we did the subwoofer time alignment. You can now do the speaker time alignments, all of them measured at large. And after that, you have the measurements with no crossover for every speaker. What you do is, for every speaker, come to EQ. These settings are for Marantz. Just click, let's make it fit to data so you see what's going on. Just click calculate target level from response. 65.5. This is for center speaker target level. What was our target? 65.9. So this speaker requires 0.4 dB volume increase. This is before equalization. Equalization will always change the volume. So wait until that, which is how you do that is go to EQ filters, upload the EQ file that I will be supplying to you. This makes it automatic, or you can manually enter every EQ band here for your receiver, whatever they are. But for Marantz and Denon, you don't need to do that. All I had to do is find where that was. I think it's this one. Yes. And another change from the first video, the Q factors are interestingly not 141 square root of 2 for the last two bands, because Marantz Denon have taken on the shortcut here, because their highest frequency they don't have the resolution to really change anything at 16,000, unfortunately. So these are the Q factors that REW will automate, and it will automate 0.5 dB steps, so you don't have to do really anything. Here it should be 20 to 20,000. Maximum boost 6, overall maximum boost 6, because that's the limit with the Marantz Denon. And flattens target 1. Minus 20 is also the lower limit. If it comes up with anything, you can enter that here, but if it comes up with something lower than minus 20, then you increase the volume of the speaker and remeasure, and then it will adjust. But it will almost never happen that you see something lower than minus 20. Also, we have entered here a gain range, so I don't think it's gonna exceed that. Maximum Q above 200 Hertz. Click all these, and here all you have to do is optimize gains. See, it just found the ideal optimal settings for every frequency band in the Marantz filter. These are the filters it came up with, if you really want to see, like that. Quite a lot of change in my center speaker. And the predicted response, with this response, for this target, it changed it into that. You can see better like this. So really getting rid of a lot of peaks here, a lot of dips here, and also some weird peak in the last area. The 16,000 Hertz adjustment, when you're checking, is weird. That shouldn't be there. Look, when you remove it, the predicted response is better. This is happening because of frequency-dependent windowing. It very seldom happens. It happened in this center speaker, for some reason, because I'm shooting a video. Well, just remove that. Don't use this one, because as you see, it just makes it worse. It's happening because frequency-dependent windowing, somehow it cannot pick up the exact point here and ends up like this. It's unavoidable, but it will not happen in other speakers, most probably. But have a look at this. It can only happen in the very high frequencies sometimes. So you go to speaker settings, audio, graphic equalizer will not be on. You have to refresh it. it's not gonna be on. Then you have to send some signal from media player, and when the signal is on, again refresh it, and then it's on. Then you can open it. Once it's there, it won't go away. You can stop media player. And this was center, right? See, we have all the top speakers as well. So center, all you do is do exactly what you see here. For 63 Hertz, it's -2 dB, -2, -4 for 125, -4, -2, -1.5, -0.5, +4, +1, -1.5. Oops, this is 1.5, this is +1. Which one did I skip? +4, -0.5, yeah. And click set. I left 16 kHz alone because this is not correct. But it will be correct for every other speaker. This is a very infrequent thing that happened in the video. And then once the equalization is there, you remeasure, obviously, center channel. Skip. Okay. Go to EQ, calculate target level from response, and now it's 64.7. This one was before EQ, it was 65.5. Now it's 64.7. So EQ really changes the SPL depending on the equalization itself. What we need to know is actually we have to make it here 65.9, for which it requires 1.2 dB volume increase. We can only do 1, so we will try 1, and then if it doesn't fit, 1.5. But all you have to do is go to speakers level and increase center channel by 1, or maybe 1.5, you don't know, and remeasure. At some point, and then finalize. When you're finalized, I will measure one more time. I love measuring from the sweeps. Not. EQ, calculate target, 65.7, 65.9 it had to be, so we are done. This is as accurate as you can adjust the SPL of your speaker, and call this C65.7. You can delete every other center channel measurement. So you do this for every other speaker, and they are now also equalized. Only things to be careful about is calculate target level. You can press it as many times as you want, it doesn't matter. The see from left channel is too high, by the way, around 3 dB, we will have to decrease it, but after EQ for the accurate match. You go to EQ filters, you upload the file, and then when it's there, you just click optimize gains, and here it comes. This is after correction, this is before. And if you keep clicking optimize gains, it will change these numbers, but don't do it. The first one is the most optimal one, and do not graphic equalize your speaker more than once. This is the only stage we will equalize it. I mean, it's an idea to crossover with subwoofer and then remeasure and re-equalize, but it's not gonna give better results, because when the subwoofer is crossed over, it's a different story. The changes it applies here will not really be changed anywhere and whatnot, and it will ask you to pump up the volume, and it will give you more equalization bands. You're gonna end up with very high volumes but almost the same sound. Don't do it, just one equalization, and this is the step. Now you remeasure with, you apply all these here in the speaker graphic equalizer again, going here, and it will again disappear, so you have to play Windows Media Player and refresh, and once you enter them, you have to remeasure and then align the SPL so that it is closest to 65.9. You will end up with full speaker set with volumes all around 65.9, give or take 0.2 decibels, and that's as close as you can get, but they will all be volume aligned. They are already time aligned, and that's all you have to do. And finally, I will show you how to crossover speakers with the subwoofer. Let me open my measurements to easily illustrate that. As you see, I have my subwoofer response here at 69.6 dB volume level, which I can show you as the target also, passing from the dip here in psychoacoustic smoothing. And this is the target level, 69.6 dB in my case. And this is the subwoofer volume aligned to be exactly, and every speaker is volume aligned to 69.6, as close as they could get. As you see, they get pretty much close. These are also after EQ, all of them, measured with the plate sweeps. Now, how do you cross over front speakers with the subwoofer? You untick everything, select front left and front right, take vector average, untick front left and front right, vector average stays, and click subwoofer, and either this at 40 or this is your crossover, 110. I obviously prefer 40, or I can do it 110 to keep this here. The problem with my front speakers are they are too large for my subwoofer. My subwoofer is a focal air sub for dome flex satellite speakers, but the front speakers are Qantas, so they're huge and their bus response is better than the subwoofers. So I cross them over at 40. These intersection points are the crossover points. Let me show you for another pair. It will be easier to understand. Now, top front left and top front right. You go vector average them. Vector averaging is important because it takes into consideration the phases of these two. And then you check where they intersect with the subwoofer. And they have to be crossovered at 95, so 90 if you have one. If you have two options, you have to choose the smaller value so that the bass is less localized. And for center speaker, you can't have a vector average, you just have to do center and subwoofer, and here is your crossover point for the center, 73.5. It will have to be 80, if not 60. And that's all for this video. I hope everything is clear now, and good luck with your correction. Bye.